Welcome to helpyourmath.com. In this video, we're going to look at the degree of a polynomial function. We're going to talk about its definition, and then we're going to look at some examples of determining the degree of a polynomial function. For the sake of this video, we are strictly talking about polynomial functions of one single variable. First, let's do some definitions. The degree of a polynomial is the largest exponent of the variable of any single term. So it's the largest exponent of the variable. So if there's an exponent on a number, we don't really care about it. We're only talking about the variable of any single term. So generally, when we're talking about finding the degree, and we're talking about polynomial functions, it's written out such as f of x equals a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. And in this case, the degree would be n, because n would be bigger than any integer where we're taking one or more whole numbers away, or natural numbers away from it. So the degree would be n if it's written in standard form. But first, the terms can be mixed up, so you might have to kind of look around and make sure that the first term does in fact have the largest exponent. And another trick to look out for is it might be written in factored form. So if it's written in factored form, we might see something like this. We'll say a sub n x. This can be any number, so we'll just say, can't use a, let's use b. And then we might have x minus c and x minus d and blah, blah, blah. And there could even be like x minus f, and there could be a variable up here. Let's use the variable q. And in this case, it's not just a single x that we're looking for, because this x is not a standalone term. It's a factor in a series of factors. So what we would have to do here is we would actually have to use the multiplication property of exponents. So we would have, if we think about where the largest exponent would be if we were to distribute all of this, which we don't want to have to do that, we don't need to do that, it would just be the exponent b plus the exponent of this, which might also be over here if there's a power here. We would take that and add it. In this case, it's 1. And then we would take this and add it. And again, in this case, it's 1. And then we would do that for all of the exponents we see. And then over here, we'd have to add q, whatever that is. It could be 1, it could be 2, it could be 17. So we have to be careful there. So in this case, the degree would be whatever the sum is there. Okay, our second definition, the leading coefficient of a polynomial. So that's going to be that term that contains the largest exponent of the variable. It's the number that's being multiplied to it. So the leading coefficient of a polynomial is the coefficient of the term containing the largest exponent of the variable. The largest, I'm just going to change it to variable exponent because this is really hard to write on. Variable exponent. And again, usually it's going to be pretty easy to determine. In the standard form, it will just be a sub n. In the factored form, it would be this a sub n times if there was a coefficient here, times a coefficient here, times a coefficient here. Okay, let's look at some examples. So we have 4 examples. We want to determine the degree and the leading coefficient of each of these polynomial functions. So first, looking at letter A, I notice that they're not written out the way they should be. They're not in standard form. They're just kind of like thrown in there. So if we want to, we can rewrite f of x. And we can say f of x equals 3x squared plus 2x minus 9. It doesn't really matter either way. We see that the degree is going to be 2. So we're going to say degree is 2. And the reason that it's 2 is because x squared has an exponent that's bigger than just x, which would be x to the first, which is bigger than having no x at all, which would technically be x to the 0. And the leading coefficient here, which we're just going to abbreviate to LC, the leading coefficient, that's the number that's in front of that term that's being multiplied to that term, leading coefficient would be 3. In our next example, again, the terms are out of order, so I'm going to rewrite g of x, and I'm going to move that negative x to the 6th first, plus 4x cubed minus 9x. Now that the exponents go in descending order, we can see that the degree here is 6, and the leading coefficient, so it's this minus sign, which as a number would be -1. In letter C, we see that we have it in factored form. So what we would do is we would take each x, so this one has an exponent of 1, this one has an exponent of 1, and this one has an exponent of 1. And here's the thing, if we were to multiply and distribute x minus 2 to x plus 9 to x plus 7, the term that would contain the largest variable, the exponent of the variable, would be when we multiply this x by this x by this x. Just in each factor, it would be kind of like the one with the largest degree. So it's going to be x to the first times x to the first times x to the first, meaning our first term would be x cubed. That indicates to me that the degree here is 3. And the leading coefficient is 1, since there is no number in front. I don't know why this is going spotted on me, but it is. Let's see if I can write a 1. Kind of. But the leading coefficient is 1. Okay, and last but not least, what would our first term be if we were to actually distribute and multiply through here? Well, it'd be negative 5x cubed times 2x times x squared times x. So it'd be negative 5x cubed times 2x times x squared, and the x squared is because of the exponent here, times x. So that would be negative 10, then 3, 4, 5, 6, 7, x to the 7th. So that indicates to me that the degree is 7, and the leading coefficient is negative 10. And just a note, even though it's not an example here, if I'm just going to put a e up here. If we just had f of x equals 6, for example, and that's it, here the degree would be 0 because there is no variable. And so if we were to stick an x with that 6, it would be x to the 0, since x to the 0 equals 1. So the degree would be 0, and the leading coefficient would be 6. And that's it for degrees and leading coefficients.